Hello, this is Wes McDermott, and in this Maya LT for Unity Developers video, we're going to take a look at texture baking as well as baking to vertices. So you can find the texture baking tools here in the UI. If we come up to the texture baking shelf, you see that we have some commands here for working with texture baking. We also have a menu here. If we are in the shading module, you can see at the top we have our texture baking menu drop down here that allows us to access the same tools as the shelf. So what we're going to do is bake a normal map for this character here. So right now we have a texture applied and we also have a normal map. And I'm going to show you how to bake this normal map directly here within Maya LT. Now, Maya LT works with a layer baking system. So by default, if we take a look at the outliner, you can see that you will have this turtle default bake layer, which is just basically the default bake layer that's always present in the scene. And you can create your own layers as we'll do now. So the first thing I'll do is I'll just enable my high-res mesh here that I have hidden. So I'll just hit Shift-H, and that will reveal the source mesh. So what you see here is just a very high-resolution sculpt that came from ZBrush. So exported out just that OBJ, and this imported that here into my LT. And we're going to use this high-resolution layer to bake normal information down to this low-res. So for now, we'll just go ahead and we'll just hide this guy again. And we'll come up to our texture baking tab, and now we're going to come over here to this bake layer editor turtle. And so this is going to open up the turtle bake layer editor. And so as I said earlier, by default we have this turtle default layer already enabled for us in the scene. But what we can do is we can actually enable multiple layers here. So each layer, and this works very much like a rendering path system if you want to think of it that way. So each layer will have its own bake settings associated with that. So you could actually, if we go ahead and select this character here, and we'll just start, we'll create a new layer. And so with that selected, I'll just edit the layer and we'll just name this. So I'll just call this Earl, and I'll hit save. And so I now have this Earl 1 layer. And so now I have the ability to add target and source surfaces. So there is other places we can do this, as you'll see here in just a bit when we take a look at the actual render options. But for now, if we just do this here and we associate these target and source surfaces with this layer, it's a pretty nice visual representation of what's happening. So if we got this object, we'll go ahead and hit add selected. So we've added this target surfaces here, this Earl shape. So this is our low res target surface. And now we're going to have this source surface. So we'll just come over to the outliner. I'll select this Earl high, and then we'll just add selected. So now we have our target, or our low res, and now we have our source, which is our high res. And so what's really interesting about this layer system is that we could add multiple objects underneath these target and source surfaces. So in this case, we have this very simple mesh, and it's just a single mesh, but we could have had this character could have different pieces, like maybe pieces of armor, or a helmet, or different things like that. And we can actually add all those extra pieces in here, so we can have multiple objects associated with one of these bake layer sets. So if we were working with multiple meshes, we can actually click this scale and texture size, which is going to open up this editor for us. Now, this editor will assign texture size to each object that's associated in the bake layer. So here in this window, we would see each one of these objects that are associated with that bake layer. We would see them here, and we'd have some information about their resolution on the basically the max X and Y resolution here. So for instance, Earl shape, you can see that we're 2K here, 2048 by 2048. Now, in the object with the largest area in this layer is found, and all the other texture sizes will be scaled in relation to that current area. An object can never have a smaller texture size than this minimum and max resolution that you would set up here. Now here we have this shared UV set. Now the shared UV set functions just the same as the texture sizes, but instead of calculating resolution, it calculates the relative UV spaces. The UV padding here, this little slider that we have, will determine the space between the different UV patches. So now that we have our bake layer set up, we'll go ahead and take a look at our actual bake settings. So now we'll go ahead and just click this button here on our shelf. This will bring up our texture bake settings. And so here you'll see we have a couple tabs here. This is sampling. We have global illumination settings that we can work with. Here on our sampling, we have two types. If you think about the renderer itself, we've got the preview render and the bake. So for most cases, you're going to use this bake setting. The preview renderer will allow you to just render a preview. Now you can't save this image, but you're just going to render a preview of what you're looking at here inside the render preview window. So again, we're just going to be working with bake in this case. And now we're going to come all the way over here to our baking tab, and you can see that right now, since we have a layer that we've already created, it's set here. So we have our bake layer set to Earl 1, and we also have our default layer. And like I said before, you can switch between these layers, and depending on which layer you're on, all of the bake settings here are going to change depending on which layer you're working with. So you can have multiple layers with multiple bake settings that you can work with. So let's just kind of run through these settings here, and we're going to take a look at what the most important settings here. And like I said, we're going to be looking at baking a normal map, so we'll be focused on that. So here you can see that we have our target surfaces and our source surfaces. Now these are the same target and source surfaces that we set up utilizing our bake layer editor, so we don't have to worry about these. Now the next thing we'll take a look at is the transfer settings. So here we have some settings for controlling the raycast, or the ray that's sent out in the scene. So Turtle is going to perform a raycast from the low-res surface to the high-res surface. A ray is sent outwards along each vertex normal, then at a given distance the ray is cast back inwards. Wherever the ray intersects the high poly mesh, it will sample the normals from it. And we can control the sampling ranges by adjusting the front and back ranges as well as the front and back bias. So we have these front range, back range, and then front and back bias settings here. And then we have this sampling preset. So if, for instance, closest, you can see that it basically is just going to set these sliders up for us. If we drop this down to inwards, it's going to make a change. And then also if we drop this down to outwards, it's going to make a change. So what the front range does is it sets the max distance that will be traced in front of the target surface when searching for the source surfaces. If surfaces are found both in the front and behind, the closest one will be used. Now the back range sets the max distance that will be traced behind the target surface when searching for the source surfaces. Again, if the surfaces are found both in the front of and behind, the closest one will be used. And then finally you have these bias settings here, again for our front and our back. And what this does is it sets an offset distance for the origin of the front and back sampling ray when searching for source surfaces. This setting can be also negative, so that you can basically reverse that direction. So again, if we take a look at this sampling preset and say that, well, we want to do inwards, you can see that, well, this is actually going to work here with our back range. So notice that the front range is set to 0. The back range is set to 200, and then basically we put a back bias on this, and it's set to -100. And same thing, so this is doing an inwards, basically an inward sampling. If we do an outward sampling, it's just going to change the controls here so that we're basically have a 200 setting here in our front range, and our back range is set to 0. Now for this case, in this example, I'm just going to leave this at default and do closest. And so you can see here that it's basically going to do a both a front and back range setting here. So it's just, this is kind of like just like an average here as it sends the ray out both through the front and the back. And then there isn't really a front and back bias set to this, so they're both set to 0. And so this is just basically kind of like your default setting. But you can tweak this individually. You can use one of these presets, or you can set this up however you want. So the big takeaway from this is these settings here are just there to control how the ray is cast into the scene. So how the ray is cast from the low-res target mesh to the high-res, and how that normal is sampled. So we have a few more settings here that are grouped in this transfer settings. We have our transfer space, so we have world space and object space. And what that refers to is the space in which this mesh or the source mesh is located. So for instance, we have world space here. If I just go ahead and just re-enable that high-res mesh, you can see that these two meshes are overlapping. So this would be transfer in world space. Now, if I had this high-res mesh or the low-res mesh like off to the side or somewhere else, I could actually transfer that in object space. So in this case, my two meshes are overlapping, so we're going to go ahead and just leave this here at world space. So the next thing that we have, just hide that, we have selection mode. So our selection mode, this basically selects how Turtle chooses what surface to sample. And so, for instance, we have our first option here, which is distance, and it chooses the closest surface in front or in the back. We also have best normal, and so it chooses the surface with the same normal as the sample point. And then finally, we have distance with flip normal, which chooses the closest surface and flips the normal if the direction is backwards. So in this case, for this guy, we're going to go ahead and just leave this here at distance. And again, what that's going to do is it's just going to choose the closest surface in the front or the back. And then here we have our mismatch. So if a mismatch is found, what happens here? Does it use the background or does it use the target surface? Here I'm just going to say just use the background. And then this setting here is pretty important, this ignore inconsistent normals, and this is on by default. And so with this option, you can choose to ignore the intersections where the normals of the high res and the low res surfaces are inconsistent. So basically, the vertex normals are pointing in opposite directions. The search will then continue until a surface with consistent normals is found, or no surface is found at all. This will help you to pick the right surface intersection in areas with both front-facing and back-facing surfaces. So areas like this would be like the ears, around the ear areas, or the armpit. So in this character here, it would be like right here around areas in this armpit. So now let's just move down to the next section here. We've got common settings. So we'll close up transfer settings. Let's take a look at our common settings. And here we have the ability to work with our normal direction. So we have a few options here. So the surface front option is using the original surface normal from the low res mesh. And then here we have the surface back. So that's basically the surface back flips all the normals. And then finally we have this other option here called the facing camera. The facing camera flips all the normals that faces away from the camera. So here, and by default, I'm just going to use surface front on this. So I'm using the original surface normals of my mesh. And so here under texture bake settings, now this is the dialog where we can actually start to set up our texture. So here we have like default width and height is 512. So let's just say that, we're going to bake, a 2K map. So we'll say 2048 by 2048. Make sure I get that right. And then we'll have a few settings here that we can work with. This conserve rasterization. Let's go ahead and just enable this. And what that does is it solves baking problems for triangles that are thinner than a single pixel. So just go ahead and you can have that on. You have a few options here, like you can actually save this to file. So that's what we're going to do here. We're not going to save this to the render view because here in my LT, from the render view, we're not going to be able to save that image. So we're going to save this to a file, and then you could just pick what directory. So you just have like a normal directory file dialog here that you could use for that. And then here for the file name, you have you can name this anything you want. There's a couple variable flags here that you can use. If you can look in the help documentation for MyLT, it'll just give you a couple of these flags here that you can put in that'll just help you to rename your file, or you could just pick whatever you want. So in this case, I'm just going to leave it at default. File format, I'm going to just go ahead and put this down here at PNG. And then these two options here are really good here. So we have bilinear filter and our edge dilation. So underneath our bilinear filter, what this does is it just dilates just enough to cover the pixels that are missed due to any of the bilinear filtering of the texture itself. And so just go ahead and have that enabled. It's enabled by default, and then your edge dilation, by default it's set to 5. And this is a really good setting because this sets the number of pixels to stretch along the texture borders. So just real quick, if we were to just, let me just go over here to my UV texture editor, and I'll have this guy selected here, and let me just turn off the texture for this and we kind of zoom in. So here's our texture border here. And so what this edge dilation is going to do is it's instead of just placing the bake right here at the edge border, it's actually going to dilate this a bit. So it's just going to just stretch these pixels out. And so what it does is it helps to eliminate bleeding problems. So especially if filtering is used on the baked texture, and this will really come into play inside of Unity if you're using bitmaps, because what it'll do is it'll help to prevent seams from showing on the map, because we'll have this kind of this texture bleed going on here. So you definitely want to make sure that you have this set, and this number here at 5 usually default works pretty good for all the situations I've used it in, but it could be different. So again, it's just something that you'll need to check. So here's an example where I have placed my normal map into the color channel here. So if we just kind of just move this bake window out of the way, all I did was just inside the color material, I just placed my normal map that I baked earlier with Turtle. And just to kind of give you an idea of what that edge dilation is doing here. So here, let's just bring this window back again. So again, here our edge dilation, you can see a setting of 5, and you can see that what's happening is right here we have our UV border here. So if we just take a look at this edge here, this is going to be our UV border, or better yet, if we just toggle our texture border here, you can see that edge dilation is basically just moving the color value of that just outside of that border. So what happens is, especially when you have to recompress the texture, especially what happens during bitmaps as the textures get smaller and smaller, what happens is during that filtering process, you'll get a seam right across here if these texture values don't extend beyond that. So again, edge dilation is a really good setting to have. Again, it's on by default, so just something to be aware of. And one other setting that we'll cover is way down here, this primary winding order. And so this guy here is pretty good because it controls which polygons to bake if there are polygons with overlapping UVs. So in a sense that, you know, in our bake set here we have like multiple objects and some of those UVs are overlapping, especially if you have actually a better example would be if you had mirrored UVs. And so this can control, you know, how baking polygons with mirror UVs should be handled. So you can actually control your winding order on this to see, and that can help with that situation. So now we'll go ahead and just bake our normal map. So now I'll come down here to my output. So you see if I just expand this output section, we have some different maps we can bake. If we come over to our shader outputs, we don't want to have anything enabled here, so we're just baking the normal map. So I turned off full shading, and I'll come over here to my normal map. I'll just enable normal map. Our coordinate system will be tangent space. You can see that we could also do object and world space if we wanted. And then we also have the ability to modify some of these channels here depending on, you know, what your target application is going to be. So if you needed to invert or flip anything, you could. Also here we have the option to use face tangents. So if I could use, you know, like the polyface tangents instead of the actual vertex tangents. And so now with this enabled, we can just go through the process of baking. So you can see that first thing we did was we just added a target, added a source, then we went through and we just set up the way that the ray is going to be sampled in the scene. And then we went through our common settings here and we determined how the surface was going to be found. Then we just went through our texture bake settings and set up, you know, our resolution, what image format we want to work with, and added some edge dilation here. And then once all that was in place, we just enabled the map type, so in this case normal map. And now we'll just come over here to the top underneath our texture baking. We can just click this button here, or underneath texture baking, the top menu, we can click bake. So let's just click our bake window, our bake option here, and this is going to bring up the texture baking view window, and you can see that nothing is showing up. What I have forgotten to do was just enable the high resolution, so we'll just enable that, or actually had that turned off or hidden, so we just want to make sure we show hidden, and now we'll just do that process again. Opens up the texture baking view window, and then here we're just going to go through the process of just baking out that tangent space normal map. And so here we go. Our normal map has been baked for us, so we can actually preview that here inside the texture baking preview window. We'll go ahead and just close this out. So actually, let me bring that back again, because here underneath our texture bake settings, you recall that we actually set a directory for this texture to get baked, and so that's where that file is going to be saved. And so we would just import that texture in and apply it to the bump mapping slot on our material. So as an example, I'll go ahead and select the low resolution here underneath this Fong material. I have this bump mapping slot. I'm just going to go ahead and click this button here, and then I could just go and create a file node, and then I'm going to set use as bump. I'm actually going to change this to tangent space normals, and for the bump value, we're actually going to here go and browse out to the texture that we baked, and we'll just apply this, and that is how we apply the normal map to this model back inside of MyLT. So now let's switch gears and let's bake some information down to the vertices of this low-res mesh. And so what we're going to do is we're going to bake some diffuse color information from this diffuse texture, and we're also going to bake some ambient occlusion down to one single color set. And so let's start by coming up to our texture baking, and let's go to our bake layer editor, and let's create a new layer. So I'm going to click the new layer button, and then we'll edit this layer, and let's just call this URL_VC for vertex color, and we'll hit save. Now let's associate a target surface with this, so we'll go ahead and just grab hold of our mesh here in the viewport, and then we'll just click add selected. And now we can close out this window, and now we'll go back to our texture baking window. So here we'll just go ahead and open up our texture bake settings, and now we have a new layer. And so, for instance, we can actually set this bake to, we're going to set this to vertices. Now notice here with our bake layer, if we go back to our original, our bake to goes back to its original position or original mode here of texture. And if we take a look at our normal map, you can see that our normal map is still enabled. If we come over here to our texture bake settings, all these settings have been retained for us. If we go back to URL_VC, you can see that all this stuff has been just set back to the default. So now we have a new layer that we can work with. So like I said, we're going to do bake to vertices. So let's come all the way down here to our vertex bake settings, and let's go ahead and just set this up. So for our sampling mode, we have two modes here. We have per vertex and triangle subdiv. So per vertex takes one sample per polygon vertex, and triangle subdiv takes a number of samples over each triangle and accumulates the results to the vertices. And so if we go ahead and just turn this on, this is controlled by our min and max samples here, and then we have this vertex bias control. So this vertex bias, if we had this set all the way here to 0, what that does, if we just zoom in here on our mesh, and I'll go into vertex mode, what it does is it takes a sample at each vertex. So it's basically a one-to-one sample for each vertex. As we start to increase this bias, the sample will actually start to move towards the center of the poly. So for instance, if we pull this value all the way up to 1, the sample's not going to happen at each one of these vertices, but it's going to happen more along the center of the polygon. Now in our case, since we want to actually bake some ambient occlusion, we are going to want to bias this vertex. So I'm going to go ahead and just give it just a value around maybe 0.4 or so. So not exactly in the center, but just around this area. We're not going to use per vertex in this case. So what we're going to do is use this triangle subdiv. It's going to give us a little bit more of a smoother result. Our min samples, so we could just go ahead and just change this maybe to 4 and maybe up to maybe 48. Well, here, let's do this. Let's change this to 16 and 48, and we'll keep this vertex bias. Let's just go ahead and just put this at 0.5, just make sure we get some just nice numbers here. And then we have some options here to save to a color set or overwrite the existing color set. So we're just going to make sure that we save this to a color set, which we can actually take a look at and work with within the color set editor. And then here we can choose a name for the color set. So we're just going to go ahead and leave this at default. Again, just like we did with our texture bake settings, we had this little flag option here that we could use that would just pull some information here from the attribute editor about our shape and put that in here. So you're actually going to see this tag here, this $P is actually going to be the output pass name. If we wanted to use the shape node, we could actually use the $S. And then what we want to do is take a look at our blending here. So we have the option to disable, which means no blending, and then we have blend old colors and blend passes. If we look at blend old colors, this blends the new colors with the old colors. If there's an existing color set of the same name, so you have to have the same color set name. If we go ahead and use blend passes, which is what we're going to use in this case, this will actually use the multiple output passes, and it will blend between these passes, and it'll create a single color set for that. So by passes, what I'm referring to is if we come all the way down to this shader outputs, we have these different outputs or passes. And so we're going to turn off full shading, but what we do want to work with is albedo, meaning just the color from this texture, and then we're going to enable this custom output. And now you can see that this custom shader slot becomes active for us. And I'm going to go ahead and click this button here, and I'm going to create a new render node. And so if I just click my surface here, you can see that we have this basically is OCC, meaning occlusion sampler. So we're going to go ahead and just use this. So this is a turtle occlusion sampler. If we go ahead and move our texture bake settings window out of the way a bit, here in the attribute editor, you can see that we now have the ability to work with some settings for this occlusion. So our type could be ambient occlusion or reflection occlusion. Our output is going to be occlusion. It could be vectors and occlusion, and so on. We have the ability to change the min and max color, adjust our sample raise, and quite a few settings here to adjust how this occlusion is going to work. But we're just going to leave it at default for now. So now if we come back up here to the top, underneath our use blending, we're going to be blending these passes. So we're going to blend the albedo with this custom occlusion sampler. And so now we'll come up here towards the top, and we'll have a few more tweaks here. So we have our RGB blending, so you can see that we have a few blending modes here that we can use. We're going to use multiply because, again, when we go to blend these, we want to take the ambient occlusion and multiply that over top of that albedo color. So we're just going to switch that over there to multiply. And so that's pretty much going to cover everything. One other thing that we could do is if you could enable this vertex color filter, and that will just apply kind of a smoothing over the colors. In our case, it'll just smooth things out a bit too much, so I'm just going to disable that, but just so you know that you can actually enable that and filter the results a bit with that. So now that we have everything enabled there, all we can do now is just go through the process and just hit the bake button and actually bake our settings here to the vertices. So we'll go ahead and just put this back into object mode. We'll come over underneath our texture baking tab and we'll click bake. And now we've baked that information. And so here you can see, let me just close this window. what we have right now is we're actually viewing the vertex color, but we also have our normal map applied. So if we take a look at our normal map, our bump mapping is still applied to this. If we go ahead and take this bump mapping and let's see if we can just ignore that here, you can see that this is just the vertex color information that we're looking at now. And so if we were to go and take a look at our polygon menu here, and we can come underneath our color, we can take a look at our color set editor, and we'll select our object. You can see that a color set has been created for us. It's called Bake Blended, and this color set here is again that that blended option between that albedo color and our ambient occlusion. So here you can see that we have some ambient occlusion here around the armpit, neck, and in the mouth and things like that. So as you can see, it's quite simple to use Turtle to bake out several different types of passes, whether it be using these bake layers. So again, here we've set up a layer that we could create an actual normal map, and then we also created a layer that allows us to create some vertex color, where we were able to blend our albedo and a custom occlusion sampler pass onto this and blend those down into one vertex color. So now what we can do that color data has been saved or baked down to the vertices is we could select this object and we could export this out FBX or OBJ, and we could have that vertex information go with us, that vertex color information go with us as we bring this back into Unity.